Okay, so like imagine planning a mission to Mars. You need rockets, oxygen, and got to think about how the astronauts are gonna like stay sane up there. It's a lot, even for like the smartest AI, right?
You're absolutely right. Trying to get one AI to do all of that is, well, it's a recipe for disaster. That's where multi-agent systems come in. It's
Right.
like instead of one super AI, you build a whole team of AI specialists.
Okay, so we're talking about like specialized AI agents instead of one AI trying to do it all. So what kind of specialist are we talking about here?
Think of it like this. You could have one that's amazing at searching through data, right? And then another one that's like a math genius. You could even have one that's learned to use, like common sense reasoning.
Which is something AI usually struggles with, right?
Exactly. It's like the holy grail of AI in a lot of ways.
Yeah. It's like we're building a dream team of AI, right? Each one with its own like super skill. I can already see how this could be a game changer, but I'm guessing it's not as easy as just throwing them all together and seeing what happens, huh?
You're totally right. And that's where this research paper we're looking at comes in. It's all about something called agent-oriented planning,
Yeah.
basically figuring out how to manage these AI teams.
So we need like a project manager for our AI dream team.
Exactly. They call it the meta agent. But yeah, AI project manager works too. And its job is to take these super complicated problems like, planning that mission to Mars and break them down into smaller tasks that the specialists can actually handle.
Can we walk through like a specific example just to make sure I'm following along?
Sure, let's stick with something a bit simpler than Mars for now though. Haha. Imagine you ask this system, how much more expensive is a BMW X5 than a Tesla Model 3?
Okay, I'm with you. So how would our AI dream team tackle that question?
So the meta agent, our AI project manager, would jump in and start delegating. First, it would figure out that we need to know the price of each car, right? So it would give that task to the search agent, the one who's great at finding information.
Makes sense. That's something a search agent could handle, no problem. Then what?
Once the search agent finds those prices, the meta agent would call on the math whiz to, actually calculate the difference.
Yeah.
It's all about making sure the right task goes to the right agent.
And this is just like scratching the surface of what these systems could do, right?
Absolutely. Even this simple example shows how these multi-agent systems can change how we solve problems. It's not just one AI trying to be good at everything anymore. We've got specialized AIs working together, just like, we do in the real world.
That's what's so cool about this. We're like building AI teams now. But just like with human teams, I'm guessing it's tough to make sure they're all working together effectively.
Yeah, you hit the nail on the head. The paper calls this the coordination problem. Just having a bunch of AI specialists isn't enough. We need to make sure they're working together smoothly, and that is way harder than it sounds.
Yeah, because we don't want our math genius trying to write code or our search expert getting lost in like a philosophy debate.
Exactly. And that's why this whole idea of agent-oriented planning, having that meta agent to manage everything, it's so important. The research actually talks about three key principles that make this kind of AI teamwork actually work.
All right, let's hear them. What's the first one?
The first one is they call it solvability. Basically, it means that any subtask that the meta agent assigns, it has to be something that one of the AI agents can actually solve.
Solvability. Yeah. So, like, you wouldn't ask your accountant to, I don't know, bake a cake, right? Each task has got to be something that the AI is actually like built for.
Exactly. Going back to your car example, asking that search agent to find prices, that's solvable because, finding information is what it's good at. But if you asked it to tell you, like, which car is better, the BMW or the Tesla, well, that's way more subjective. Even a human would have a tough time with that.
Good point. Okay, so solvability. That's about making sure we're giving our AI agents tasks they can actually do. What's next?
Next is completeness.
Ah.
What that means is all those little subtasks, when you put them all together, they should give us all the info we need to answer that original, more complex question.
Completeness. So we're not missing any pieces of the puzzle. How do we make sure that happens, though?
That's where our AI project manager, the meta agent, comes back in. It's got to keep the big picture in mind, right? Like with the car example, if it only told the search agent to find the BMW's price, well, we'd know how much that car costs, but we wouldn't know how much more expensive it is than the Tesla. We'd have part of the answer, but not the whole thing.
Right, right. We could nail that solvability thing. All the tasks are things the agents can actually do, but we could still end up with a bunch of like correct answers that don't actually tell us anything useful if they don't like
Well,
fit together.
exactly. And that leads us to the third principle, non-redundancy.
Okay, so no busy work for our AI team, just like
Yeah.
we want to be efficient in our own work, right?
Exactly. Non-redundancy basically means that every single agent on the team, its work, should be adding something unique, something essential. We don't want two different agents searching for the same price. We don't need the math whiz double-checking calculations for no reason, you know?
Streamlining the workflow, even for our AI teams. Okay, so it's one thing to like lay out these principles, but how does an AI system actually put them into practice? That seems like it could get really complicated.
Yeah, you're right. It's tricky. But the researchers in this paper, they came up with some really clever solutions. One of them is what they call a reward model.
A reward model, are we like giving our AI gold stars or something?
Uh-huh, not quite. It's more like a prediction tool. The reward model helps the meta agent estimate how likely an agent is to actually succeed at a task before it actually assigns the task.
Oh, so it's like checking to see if we're on the right track before we actually get going.
Yeah, exactly. And to do that, they use these things called representative works.
Mm.
Basically, it's a record of all the tasks an agent has done well in the past, like a portfolio almost.
So the meta agent can be like, okay, this search agent has found prices for like cars, houses, all kinds of stuff before. So it'll probably be good at finding the prices for these two cars.
Exactly. And the reward model looks at those representative works and it gives the meta agent a kind of confidence score. High score, good chance of success, low score. The meta agent knows it might need to, maybe rephrase the task or break it down even more.
So the reward model, it's like a safety net, making sure the meta agent is making good decisions about which agent gets which task. It can even suggest changes. But what if, like, a task just doesn't seem solvable, even after the meta agent has, tried to reword it and everything?
That's a great question. And it leads us to another important part of this research, planning in detail.
Planning in detail sounds kind of like, I don't know, intense.
It kind of is. So remember, the meta agent's whole job is to take those big tasks, the complicated ones, and break them down into like bite-sized pieces the other agents can handle. Planning in detail. It's basically saying, okay, this task, it's still too much for any one agent to handle. Let's break it down even more.
So it's like giving the meta agent a power tool for those really, really tough problems, the ones that don't fit neatly into those like predefined boxes.
Exactly. And, so this whole thing doesn't go off the rails. The researchers, they made sure to build in some safeguards. Like while it's doing this plan in detail thing, the system, it's automatically checking for redundancy. We don't want to accidentally create a bunch of duplicate tasks, right? That kind of defeats the whole purpose.
All right, got to stay efficient. But
Hmm.
this whole system, it all kind of hinges on the meta agent, like it's got to be really good at its job. How do we actually make sure that it's up to the task, especially with all this like extra complexity we're throwing at it?
That's the million-dollar question. And the researchers, they definitely thought about that. They built a feedback loop right into the system.
So the meta agent isn't just like calling the shots, it's learning from its mistakes too. How does that work?
Okay, so imagine this. Every time this multi-agent system, it actually gives the user a good answer, it remembers that. It remembers the tasks it made, which agents got which tasks, the whole playbook.
So it's like it's building up this like knowledge base of what works and what doesn't.
Exactly. And then all that info, it gets fed back into the system. And the system uses it to make everything better. The reward model, those representative works, it all gets a little bit smarter over time.
Constantly learning, constantly improving. I like it. So we've got this system. It's getting better at figuring out the tasks. It knows how to pick the right AI for the job, and it can even spot problems before they happen. This AI teamwork thing, it's kind of blowing my mind.
It's definitely a game changer. And it makes you think, right? Like, as we keep building these AI teams, how's that going to change the way we do things?
Whoa. So we're building AI teams now. Does that mean, like, we need to learn how to manage AI? Like,
Mhm.
it's the same way we manage people, AI team dynamics, communication styles, maybe even,
Hmm.
like, AI personality clashes?
No, that is a fascinating question. As AI gets more, well, more collaborative, I think our role in all of this, guiding those collaborations, it's only going to get more and more important.
That's a pretty awesome thought to leave on.
Yeah.
Like, the future of AI, it's not just about making, like, smarter machines. It's about making smarter teams. We could be combining the best of what humans can do with the best of what AI can do. It's a whole new world of possibilities.
Couldn't have said it better myself. We're just scratching the surface of what AI can do. And I, for one, am excited to see where it goes next.